All right, my darlings. Let's go ahead and answer this question. Do we believe that Cheyenne, Wyoming, Des Moines, Iowa, and San Francisco, California have the same climate?
No.
Okay, we have one person, have we started this yet? Great, we have one person that says no. How many of you agree with that person that says no? Wow, I also agree. Oh, man, I marked you absent, Billy. Gotta go fix that. I agree that the answer is no. With your parent share partners, turn and talk. Why no is the, or do they not have the same climate? Why? What is your explanation? What is your evidence to back that up? Go ahead and talk that out.
Precipitation is different, so, and their weather is
Sam,
different, so they're not gonna have like the same, or their temps different, so they're not gonna have the same weather going on.
Yeah, like the temperature, precipitation is very probably a big difference.
Same climate. Okay, they do not have the same climate. B/C, because we know this. Why? Someone raise your hand and tell me why. Why do we know that they do not have the same climate? Ethan.
The temperature and precipitation varies a lot differently throughout the year.
Okay, I like that because they have different temperature and precipitation totals. Totals during the year. Ah. Yeah. If we look at the graphs that we put together, we can see that they have very different temperature and precipitation totals throughout the year. And we are going to be using those graphs that we put together yesterday for the remaining of our time looking at what causes climate and why do different things have, different areas have different climates. So why do we think that they do have different temperature and precipitations during the year? I mean, we know why we think they did because we saw them, but what could be reasons why? Jaren?
I'm not confident.
Okay, no problem. Sam?
The temperature at San Francisco is regulated by the ocean.
It could be that the temperature of San Francisco, we've got San Francisco on the ocean, and Cheyenne, Wyoming, and Des Moines, Iowa aren't. Maybe that's what's different. Yuma?
Latitude.
Maybe it's the latitude. We can look at that one right now. Let me go ahead and pull up a map of latitude. These are some of the things I'm hearing you talk about based on what you read in your reading. So let's go ahead and look at latitude. First of all, what is latitude?
Is this relation?
Okay, it's this direction, so it's distance from the equator. So latitude is distance from the equator. Let's imagine that this is 0 degrees latitude. It's not, but let's just imagine that that is. So we have to look at the distance that these cities are from the equator. One is here, here, and here. Are they a big difference in latitude from each other?
Yes.
They're not.
Oh.
They're actually not. In this case, latitude doesn't have anything to do with why these three cities are different temperatures or precipitation. But Jared and Yuma are right. In some cases, for sure, Iowa is definitely going to have a different climate than Florida because of the latitude, right? It's much closer to the equator, and so it's going to get much more what? Florida's going to get more what than Iowa is?
Direct sunlight.
Direct sunlight throughout the entire year. So if we're looking at the temperature of Florida on a graph, it's probably going to be much more linear. It's probably going to be much more even and steady throughout the year. Or when we looked at the graphing of Iowa's temperature, it goes really hot in the summer and then it gets really cold in the winter. So we don't have a really cold winter in Florida, right? That's why so many people like to go to Florida in the winter. So while you're right, latitude can change climate. In this case, latitude does not have anything to do with it. But we are going to go ahead and start addressing why is it that these three have different climate. let's look at those maps. Can everybody get out your maps, please, that you put together, not maps, graphs, please, put together that, from yesterday? I'll pull up those graphs for those of you that don't have it, so that you can see what it looks like. I'm gonna start with the temperature graph. Here's the temperature graph. We've got Cheyenne, Wyoming in red on my graph. We've got San Francisco in green. We've got Des Moines, Iowa in blue. And then I asked you some questions about the graph to make you really look at the graph. Time is on the bottom. Anytime we have time and a graph, it's always going to be on the x-axis. And then over here is temperature changes. What do we notice? What do you notice? Turn with your pair partner and let's talk about similarities and differences with temperature. I'll give you 10-second countdown on that. On your marks, get set, go. Allie, turn and talk to Zai.
Des Moines is a lot more red.
Or similar between the
The
similar.
same thing, like Wyoming and Des Moines
Are there any that
look
are
more similar because San Francisco is like affected by the water.
Which two cities are really similar in their temperatures?
San Francisco and Des Moines.
San Francisco is the green one.
Oh wait, Cheyenne.
Cheyenne, yeah. Cheyenne, Wyoming, and Des Moines, Iowa are very similar, but they're not exactly the same. If they were exactly the same, their line would be one right on top of the other. But they have similar patterns. They show that they're really both very cold in winter, and their warmest time of the year is in summer. California has more of a steady temperature throughout the year. It doesn't get too cold in the winter. It doesn't get too hot in the summer. It stays kind of nice and steady and even. Everybody loves the climate out in California because they like that nice, steady kind of temperature. Not too hot, not too cold. Okay, which one has a warmer summertime? Des Moines, Iowa, or Cheyenne, Wyoming? Des Moines, Iowa, we know that because the blue line goes up higher. Which one has a colder winter? Cheyenne, Wyoming, or Des Moines, Iowa? Des Moines, Iowa, because it goes down lower in the winter months. Let's go ahead and look at the precipitation. Flip your graphs over and let's check out the precipitation data. All right, again, what similarities do we see? Cheyenne, Wyoming, and Des Moines, Iowa. Now, do they have the exact same precipitation throughout the year? But they have a similar pattern. So there must be something similar with those two that is very different than San Francisco. Cheyenne, Wyoming gets most of its moisture in the summer months, just like Iowa, and they both have kind of a dip in there, just like each other. But which one gets much more rain during the summertime? Des Moines, Iowa gets much more rain during the summertime. What about San Francisco? What happens to it in the summertime?
It just doesn't get any.
It gets really dry. In the summertime, it's very dry there. San Francisco gets most of its moisture or precipitation in the winter months. If we can see that, in the winter months, it gets most of its precipitation. So we're going to figure out what's going on here. What is happening with Iowa and Wyoming? Why is it so different than San Francisco? And what is it that's similar but different between Iowa and Cheyenne? So what we're going to do is we're going to continue our investigation today. We looked at latitude and we said, latitude doesn't really have anything to do with it. So right now what we're going to do is explore what Sam said about maybe it's that one of them is near water. So we're going to go ahead and look at the lab that you picked up on the way in, and we're going to look at the differences in different surface materials on our planet. Could you please get out your lab that says heating versus cooling? Not what causes climate, it is heating versus cooling. It's a lab. So the purpose of today's lab is to discover how the heating and cooling rates of different surfaces impact our climate. It is very important that you read and follow the directions, okay? So that you know what to do and what is expected of you. If you have questions, please reach out to your partners and then please reach out to the educator in the room, which would be me. Here's our question that we're going to test. How quickly does temperature change in water compared to soil or sand? So I want you to put together a hypothesis. I predict what? Will sand or water heat and cool faster than sand or water? Now, obviously, you're not going to put sand in sand, right? If you put sand here, you're going to put water here. If you put water here, you're going to put sand there. So right now, write something down what you think. Do you think sand will heat up and cool off faster, or do you think water will heat up and cool faster? Please fill those in. I don't want to move on until we have something down. It's not about being right or wrong. It's just, does the evidence support what you think or not support what you think? Do we all have something written down there?
Yep. I think-
Fabulous. I know Jaron does.
Yeah. I know Yuma does too, because we discussed.
There you go. So let's go ahead and look at how we're going to set this up. Notice number one, it says safety. Don't touch the heat lamp. It's hot. So please be careful with these heat lamps. They do have a bulb on them that is rated as a heat lamp, so be careful. We want to make sure that we're centering our cups under the heat lamp, and we want to make sure that the heat lamp bulb is 15 centimeters above the cup. So try to set yours up like this, and we're measuring from the bottom of the bulb to our surface. It says to the top of the cups. I'm fine with that. If you want to get it closer so that it's about 15 centimeters from the surface materials, you can do that. We're not using temperature probes. I don't feel that they really give us very good data, so we're just going to use good old-fashioned thermometers. You are going to take the temperature reading in Celsius. Okay, just make sure that you're always reading Celsius. So as we set this up, notice we have sand and we have water. We want to make sure that the thermometers are in about a centimeter's depth. I figured that out for you, so you don't need to worry about changing that. You are going to have one person, though, constantly reading the sand temperature and one person reading the water temperature, okay? So every minute you're going to be taking a reading. So there's going to be a timer over there. If we look over at our data table, you're going to take an initial reading of the temperatures at 0 time. So before you even turn on the light, you're going to figure out what the temperature is that we're starting with. And then you're going to hit start. Someone's going to be in charge of the timer, and then that person's going to say, okay, it's been a minute, take a reading. And then the people that are reading the thermometers are going to tell us what to write down, okay? And you're just going to continue doing that. Don't shut the light off in between readings. Don't stop the stopwatch in between readings. The light and the stopwatch just continue. Every minute you take a reading. Then at 10 minutes, you shut the light off and you move the lamp away from those materials. Why do we move the lamp away?
Because it's nighttime. The sun's gone.
Because the lamp would still be warm. And if we don't move the lamp away, then what's going to be happening is, Jaron's right, our simulation of nighttime, right, is going to still be radiating out heat. So we got to get those materials away from the lamp. Again, don't shut the timer off. Then another 10 minutes, you're just going to keep timing. Every single minute you take a reading. Let's go ahead and flip our paper over and see what our graph is going to look like on this. I'll help you set up your graph. As I flip your paper over. We're going to use your data to create a temperature versus time graph. Notice we already have a title, and the title tells us exactly what it is we're doing. We're looking for temperature change in sand versus water. We're going to have 2 line graphs. Remember, yesterday we had 3 line graphs. Today we're going to have 2. You're going to pick which colors you're going to want for sand and water. Let's go ahead and set up the bottom. What is the bottom, the x-axis, going to be set up as? Time. Everybody write time down here, please, on this line. We are going to go ahead and have time on the bottom. What are we measuring time in?
Minutes.
Minutes. We're taking a measurement every minute. We've got 20 minutes listed. If time is there, what should be on the y-axis?
Temperature.
Nice. Let's write temperature on the y-axis. Oops, that's not temperature. What did I say to measure temperature in?
Celsius.
Right, we're going to do degrees Celsius on that. Now, our time is set up, no problem. We cannot set up the y-axis with our data until we shut off the lamp. After we shut off the lamp, we will have gone as high up as we can, and then the temperature will begin dropping. So I'll walk around to help you out with that, but we've got to wait until the temperature is shut off. We've been finding that either counting by threes has been working good, like 3, 6, 9, 12. That's been kind of effective, but we'll see what you all get for your data. All right, so I'm gonna go ahead and put you in your groups. After you are done collecting data, you're gonna be graphing, and I'm gonna encourage you to be graphing while you're collecting data, at least after the 10-minute mark, because for homework, you're gonna need to use your graph in order to answer these questions. So your homework tonight is to go ahead and work through the rest of the lab. So do you have homework in science? Yes, you do. You have homework in science. You are gonna be number 1, you're number 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 1. So this means you're going to the tables of your numbers, okay? Decide who's going to read the water, who's going to read the sand, who's going to be the timekeeper. All right, take an initial reading, please. Celsius, take an initial reading, please, in Celsius. Take an initial reading at 0 minutes. All right, my people at home, I'll show you how this is set up in our lab. Let's go ahead and see how we have this set up.
We turn it on right.
22.
Wait, you gotta get an original.
That's how we have it set up, and we're gonna have our light over it. All right, get that light bulb 15 centimeters